Hello scholars, ready for Unit 3, Bonding. Let's talk about gases. That was Unit 1. But they're coming back again. Alright, it says the noble gases are a unique type of element. So I remember noble gases, that's group 18 from the periodic table. It says Table 1 below lists forms for how noble gases are found in nature versus how other elements are found in nature. So this is like their stable form if it's found in nature. After reviewing Figure 1, record your observations before reading further. Okay, it says formulas for noble gases and other elements as they're found in nature. So here are the noble gases. Okay, yeah, okay. Here are all the other elements. Oh, I noticed this is water. CO2, O2, CH4. Okay. I'm noticing things. Make sure to write your observations. Go ahead and do that. And then when you're ready, go on. We can learn more about the noble gases. Oh look, those are nobles, but they're not gases. Unless, you know. There, that's some noble gas right there. Because he farted, get it? Okay, I had to explain that. That was sad. The noble gases are unique because of how their valence shells are filled. Interesting. What do you notice about the number of valence electrons in each noble gas's last shell? How many electrons can fit in their last shell? So here we've got helium. There's 2 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. Neon's got 8. 1, 2, 3, 4, 5, 6, 7. Argon's got 8. 1, 2, 3, 4, 5, 6, 7. Krypton's got 8. Xenon. 1, 2, 3, 4, 5, 6, 7. Xenon's got 8. Interesting. Record your observations. Did you record observations for the other one? I'm going to be looking for those, you know, so you should. Yep. Okay, so let's flip the page. What else can we find out about the noble gases? Oh, yay, more reading. Every atom is most stable when it has a full valence shell. So that means, what, 2 out of 2? Or 8 out of 8. The noble gases already have a full electron shell, and so they are very stable. Noble gases don't make chemical bonds with any other elements. They do not need to gain or lose any electrons because they already have a full electron shell. Yes, that's being repeated quite a bit. Since a full valence shell usually requires 8 electrons, this phenomenon is called the octet rule. Octet to me sounds like octopus. I think I spelled that wrong. Anyway, I know an octopus has 8 arms or legs, some sort of appendage anyway. So 1, 2, 3, 4, 5, 6, 7, 8. So there's my octopus. Okay, so octet rule. 8 octopus makes sense. Ocho, right? Atoms can gain or lose electrons to get a full valence shell, octet. Metals have a low electronegativity. Okay, I know electronegativity is how well attract electrons, and will lose electrons. So metals lose electrons. Because metals are losing electrons, which are negatively charged, they will become positively charged cations, with charge equal to however many electrons they lost. So if they lost 3 electrons, they get plus 3. Okay, I get it. Nonmetals have a high electronegativity. Okay, that means they're good at attracting electrons, and will gain electrons. That makes sense, because they're good at attracting electrons. Since electrons are negative, nonmetals will become negatively charged ions, which I know are called cations, with charge equal to however many electrons they have gained. Okay, what does this say? Figure 2, examples of metal and nonmetal forming ions to fill their valence shell. So metals lose electrons to get a full outer shell forming cations. So here the third shell has 1, right? 1 electron, and that's a valence. Get rid of that 1 valence, electron, and you're left with the second shell, which now has 8 electrons, which is full, right? Full. Like me on Thanksgiving. Okay, fluorine atom starts with 7 valence electrons. It gets 1 more, so now it has 8 and is full. So nonmetals gain electrons, metals lose electrons. Okie doke. Let's see, what else? Lewis dot structures are shorthand, so I know that's like a short cut, that kind of thing, For Bohr models, okay, I remember Bohr models are the ones with all the, the rings, like that only show the valence shell. So only the outer shell of each atom. To draw Lewis dot structures for atoms, determine how many valence electrons the atom has. I can do that from the periodic table groups. Add one electron to each side of the element, top right, bottom left, until you run out of valence electrons. Okay, so it says figure 3, example Lewis dot structures. So potassium has 1 valence electron, bromine has 7, sulfur has 6. I notice some of these are paired, some aren't. Krypton has 8. Just because you're watching, I'm going to give you bonus. So here's what nitrogen would look like. You'd do that nitrogen. Look at the periodic table. Nitrogen has 5 valence electrons. So you go 1, 2, 3, 4, 5. Electrons repel each other, so only pair them when you have to. Alright, that was a fun video. Want to see the farting again? Okay, see you in class.